important information that you are going to want to know for your test. We didn't talk too much about power. Your equation is in your physics helper, and I want to make sure you understand how to calculate it when we've got some complex circuits, or in this sense, a series and a parallel. So we just want the power through the individual bulbs. And in your physics helper, make sure you know where this is located. Power is equal to current times voltage. Now, a concept that you need to know is that power is what affects the brightness of each bulb. So, we've already looked at what bulbs look like in your series circuit and in our little lab where we had these little metal pieces and we put them together with batteries and we were able to turn on some lights in parallel and in series. So just conceptually, between a parallel and a series circuit, which one is going to have the brighter bulbs and therefore more power? Can anyone tell me? Series? It's actually the parallel. So you want to make sure, and you guys are already building these series and parallel circuits in your house, that in order for them to check that they are actually built correctly is to see that your parallel light bulbs are brighter than your series light bulbs. So we know this, just through our experimentation, is brighter. And before we actually check the calculation, we're going to see that the answer should be a larger power value for parallel than for series. So let's go ahead and look at our calculation here. So for this group, they were able to determine that because it's a series circuit, the voltage drop through each resistor or through each light bulb is going to be half of the 9 volts. Now this only works because of the fact that each light bulb has the exact same resistance. But if they weren't the same, you would actually have to calculate it, okay? So this is correct. 4.5 volts through each 4.5 volts. This is your voltage drop or the potential difference. So those are used interchangeably through each light bulb. And then now that we know the voltage is 4.5, we need to figure out what the current is. So this is where this equation or this method, VIR triangle, comes in handy. So our current is voltage divided by resistance. We already established that the voltage is 4.5, and what's given to us is that the resistance is 2 ohms. That's given in your problem. So in order to find the current, it's going to be 4.5 divided by 2, which, what's that current? Can anyone give me the calculation? 2.25? Okay, good. So we're going to, I like to use arrows as my symbol to show that the current traveling through each resistor is 2.25, and just a concept that you need to know is that if it's a series circuit, it's going to be 2.25 the entire way around. 2.25 coming out, 2.25 going in, and 2.25 through each series resistor. Okay, so these are all concepts that are actually in your physics helper. All right, so we've got our voltage, we've got our current. Let's multiply them together. 2.25 amps times a voltage of 4.5 volts gives me, what is it, 10? 10.125. And what is my unit for power? Watts. W for watts. So what is nice is this, I know, is a dimmer light bulb just because it's in series. This should be dim. This one should be bright. And the power here is 10. And we're going to double check the calculation, but the power here is 40. So that matches what we think should happen. Okay, so we're trying to find our power, which is current times volts. One thing you need to know about a parallel circuit, the voltage drop for a parallel circuit is going to be the voltage of your battery because they are directly connected to the battery. So we've got the voltage of 9 volts. Now, unlike a series circuit, the current that comes out of the battery, let's say it's coming out in this direction, is going to be different as it travels through each light bulb. And because of the fact that each resistor is equal in value, you can literally take your total current and split it in half. But we need to figure out what our total current is. The other method you can use is our current equals V over R. We've already got our 9 volts, and we've got our 2 ohms, so current is 9 over 2, and that gives us 4.5. So, if I know this is 4.5 amps, and I know this is 4.5 amps, when they come back together to the negative side of the battery, they're going to add together as 9 amps coming in and 9 amps coming out. Does that make sense? Question.
So why the series circuit was at 4.5 divided by 2
What do you mean 4.5 divided? Oh, here? The reason why is I just took the voltage drop and I for the individual resistor and divided it by the resistance that's given to us. So 4.5 divided by 2 is just my V over R. Here, the voltage is the same as the battery. So in a parallel circuit, you're going to have all 9 volts traveling through each light bulb. And so that's why this one's going to have a bigger voltage divided by the same resistance. Good question. Okay, so we established our current is 4.5 coming through each light bulb, and we're only focused on the light bulb, not the total circuit. So if I have 9 volts going through the light bulb and 4.5 amps going through it, my power used by that light bulb, the energy used by that light bulb is going to be 40.5 watts. Any questions? It's about 4 times more than the energy that the light bulb uses in a series circuit. So 10 versus 40, that's significant. So it's going to have 4 times more brightness. What about, let's go through, are there any questions on those calculations before we go over the symbols? Okay, so the ones that are most obvious, because we've been seeing these symbols throughout the entire unit. A battery is a long and short line next to each other. This is one battery. Sometimes you're going to see a bunch of these long and short lines next to each other, and each long and short line represents a positive and negative side of the battery. So if I had 3 of them next to each other, that would be 3 batteries total. So let's just say each individual battery was 1.5 volts. How much voltage would I have if I had it set up this way? If each battery was 1.5 and I have this symbol in my circuit, what is it? 4.5. I have 1, 2, 3 batteries in line. So you just take your voltage, multiplied by 3, or add it 3 times together, and you get 4.5. So this would be 4.5 volts. In your test, I'm going to give you the total voltage so you won't have to worry about how many battery symbols there are, but but I just want you to recognize that sometimes there's more than one, and so you have to count the total voltage there. The next thing is my resistor, which is pretty simple. Oops. My resistor is the zigzag symbol that you have in your diagram. The switch we haven't seen as often, and there are multiple ways to represent a switch. So let me get this back up. Your switch, this one shows a closed switch, but you can also, actually more often than not, you can show a switch that is open. And then the ones that are the most, kind of the newest symbols that we haven't seen as often are our, not voltage, but what should I put here? Instead of voltage, what am I? It's a voltmeter. And then instead of current, this would be what? An ammeter. It measures current. And it measures voltage. Now, even more than just recognizing these. This is in your vocab list, so it might be nice to add some of these concepts in your vocabulary list. Is that the ammeter is set up with your circuit in series. So I want you to notice that they're all connected to the same wire. Not series. A voltmeter, though, has to be connected very differently. A voltmeter is connected to your resistor because the resistor is the one that uses voltage in parallel. And here's the reason why. Current travels through the wire. So if you stick an ammeter in your wire, it'll measure how many charges are flowing and how fast they're flowing through it. So you only need to connect it in the middle of your wire in series. But a voltmeter measures how much energy is being used. So it takes the voltage here, voltage at start, voltage before the resistor, and then it takes the voltage after the resistor to figure out how much voltage and how much energy that resistor or that light bulb actually use. So it needs to be located at the opposite ends of your resistor, which we call parallel, in order to work. And understanding how to set up an ammeter and a voltmeter in your circuit is going to be important for your test. Are there any questions on that? It can be put anywhere, yeah. If you wanted to measure the circuit for series, it's going to be the same, right? But if you wanted to measure the amps of this resistor, you could put an ammeter here. You could check the current here, and you can check the current total if you put an ammeter there. And you can check the total here. Yeah.
On the test, if it gave us like there's an ammeter, then
Would they be equal, or okay, is that what you're asking? Yeah. So if you wanted to check what the current was, you should know that the current coming out of the battery is going to be the same as the current coming into the battery. So those are good uses for ammeters. It's also good to use to measure the current through individual resistors when they're in parallel. And then when they're in series, if you know that this current, just like your quiz, right? If you know this current is, let's say, 5 amps, then you can assume that the current through the resistor and all the way through the circuit itself is also 5 amps because it's series. Question?
I just want to clarify, if you wrote series under the ammeter, does that mean you can only be used in a series?
No. I'm just saying it has to be put in series, which means on the same wire as your circuit. whereas the voltmeter is connected independently from the circuit.
That's always the case.
Yeah, that's always the case. You always need your voltage to kind of be on opposite sides of a resistor. And we call this setup, because they're in parallel, we call that parallel. Good question. These ammeters and voltmeters are used in any type of circuit. Series, parallel, complex circuits, like the ones you have in your houses. So, how you set them up to find the current and how you set them up to find the voltage is what's most important about that concept. Any other questions? All right, so powers related to brightness. Ammeters and voltmeters need to be set up in a very specific way in order to find current and voltage. And all the other concepts that you have in your physics helper about series and parallel are going to be important for your test. Any other questions before we get into our workday? This is what it should look like. So you've got, can't see any of that. You've got your review worksheet. That's your 24th item. And you've got that extra 10 points to add up to 220. Everything else is in there. There's an extra credit crash course video if you wanted to add those notes in. But the link is kind of in the very beginning of our unit. So you have to go search for it. Let me know if you can't find it. For homework, I also posted an extra credit practice test. So that's 5 extra points if you get 100% on it toward your test grade. And then I want to make sure that you get all your stamps before class on Thursday so we can get straight into the test. So today, as you're working on your projects, if you have any worksheets that need stamps or any other materials that you forgot to get stamped, get that stamped. And if you need more time to work on materials, come in before class, so during break, to get your stamps. Okay, and then the last thing I want to emphasize, I put a demo up here of your blueprint. Everyone got the rubric for their electric house project. And though a lot of you are making some really awesome houses, I haven't seen very many posters. So here's an example of what I'm looking for. Your blueprint of your circuit doesn't have to have the house in there, but I do want your light bulbs to be shown in the same setup as how they're set up in the house. So if you have your light bulbs on the ceiling and your switch, obviously I wanted to make this a little different. Like a switch on the floor, that wouldn't be realistic, but I want to make sure that your diagram matches what your house looks like. If you have a third room, you're going to add your third room in here. You have to do calculations. These are complex circuits, so doing calculations for resistance, current, and power. If you need help on that, I recommend that you do it in class on today's workday to get help on it. And then the actual measurements, which is the bottom part of your rubric, that's going to be measured the day of so that you can show me how you can find the total voltage and the total current and the total power of your circuit. So we're going to be using ammeters and voltmeters. You're going to be doing that when you turn your project in. Each light bulb has a 50 ohm resistance, and depending on how many light bulbs you use, I've got 3-volt batteries and 6-volt batteries. The 3-volt batteries are the 2 battery packs that I have in the classroom. If you're using, let's say, 6 or 7 volts, then you might want to use a 6-volt battery pack, and you can come and test that with me as well.